Okay, so like I said, we're going to basically be looking at three properties with logarithms. The first one is called the product property. Basically, if you have a logarithm of a base and you have like something times something on the inside, like a lot of times you'll have like a coefficient and a variable. You can then separate these into two separate logs with a plus sign. So like for example, if you had 5 and x, you could separate the number, like the coefficient in your variable. That's usually where it's going to be used for. A lot of times you can kind of separate um, a variable from like a number, like, and you could evaluate the number part. Or if you have like, if you're adding logarithms, you can just multiply what you have in. So let's start looking at some examples. There's two kind of problems you're going to see a lot of times with logarithms. Sometimes they're going to ask you to condense. Sometimes they're going to ask you to expand. Condense means you're kind of like condensing it or squishing it together. Basically, when you condense, you're just going to have one logarithm. When you're expanding, you're kind of separating into multiple logarithms. You might have two, you might have three, you might even have four, or possibly even more, depending on how crazy, like what you're dealing with. So to condense a logarithm, basically the idea is using this property, remember, if you have two things added together, you can just multiply them together in a single log. So you keep the same base, so it'd be log base 2, and you would just take 7 times 4. So this would be log base 2 of 28. And one thing I want to say today, I'm going to be writing a lot of the individual steps, but feel free when you're working on these at home, like on an assignment, or eventually when we have our quiz, you can do multiple steps at once. Like, for example, if you went straight to your answer from here, that's a-okay. Like, I would encourage you, like, as you get more used to these properties, that you start kind of doing multiple steps, or what you can see, like, feel free to do them kind of in your head. But especially since I'm just introducing it today, I'm going to kind of write out all of my steps if possible, just to make sure you're seeing it. So this next one, you would just multiply what you're plugging into your logarithm function. So 25 times 4 would be 100. That would be our answer. One thing you could, like, it does say simplify if possible. Usually you're only going to do this if you're going to get a nice answer. Like, for example, this first one, we could have done that change of base formulas from yesterday, if you remember. Like this one you could do in your calculator, log of 28 over log of 2, and you would get like a decimal. I worked it out. I got about 4.81. But usually, I mean, unless you need to get like an answer, I'm not going to do that. But if you do come across something like this, remember, this is log base 10. 10 up to what power would equal 100? Well, this would just be 2. So usually if it simplifies to like a nice number, you do want to evaluate it, if that makes sense. It kind of depends what you're doing. I know it's going to be like, well, when do you have to do that? When do you don't? Usually, I mean, you're just going to simplify it if it's something that works out really nice, like you get a whole number answer. If it's like an example where you need to get like a fraction or use that change of base formula, then it's, unless they tell you I need an answer, don't worry about it. But technically, to condense it, this would be our answer, but you could also simplify it to be 2. So, this next one with variables, you keep the same base, but then you multiply like what your inputs are. So I mean, 2 times 4 would be 8. X times x squared would be x to the 3rd. So that's the idea when you're condensing. You're kind of like I said, kind of putting together your logs into one log, basically. Now we're going to be expanding. And honestly, I think questions 4 and question 5 are a little bit silly because you probably wouldn't ever do this like in an actual problem, but you could expand a number. Basically, you could think of two numbers that multiply to 6. So there's definitely more than one answer you could have because there's more than 2 factors of 6. Like you could do 6 and 1, you could do 2 and 3. But this would be log, you could rewrite this as log 2 plus log of 3. Like you could kind of expand it into more than one logarithm. Same idea for number 5, you keep the same base, but 45 is the same thing as 5 times 9. or there's other factors. You could do 15 and 3. You could do, you really don't want to do 45 and 1. I mean, like usually that's not going to really, that wouldn't really do much with you. You'd still have the same logarithm. So honestly, I think questions 4 and 5 are a little bit silly because like usually it's really not something you'll see. But you could, for example, if you had a number and you saw like a logarithm that would simplify nicely, you could kind of pull it out if that makes sense. But I'll be honest with you, 4 and 5 I think are a little bit. I really love the questions because I don't think it's something you'll come across. But for question 6, this is really where you'll want to be able to expand. Like you could rewrite this as log base 2 of 5 plus log base 2 of x. So that's actually pretty useful because then you could evaluate, like the number one you can pretty much evaluate, and then you got your variable one kind of isolated. So that can be useful. So any questions so far about the product property? One thing to notice, and you'll notice in all of these problems, this only works if you have the same base and your bases are never changed. Remember, the base is like your small number with your logarithm, but that number is never going to change when you're dealing with these problems. So just kind of keep that in mind. And for example, if you had different bases, well, then you couldn't use these properties. So, I mean, that is one thing that is important. I mean, there are ways to change logarithms base. So like, for example, if you did have different bases, you could change them to have the same base kind of thing. There are ways to do that. But that really won't be an issue in this class. For example, 2, because remember, remember, if you ever have a logarithm without a base, that is log base 10. So that's why like I wrote it as base 10. I guess I didn't really need to put that base 10 either. Like you could have wrote the answer without it. I can't just erase it, but you could have just wrote that as log of 100 as well. So I just kind of wrote the base when I was thinking about what it would simplify to. Okay, but I've seen many other questions. Let me know if that didn't answer your question though. Our next property is going to be called the quotient property. Basically, if you have log base of a fraction or you're dividing something, you can separate it into 2 separate logs that are subtracted from each other. Or you also could write 2 logs that are subtracted. You can kind of combine them with division. So like keep in mind these properties kind of work both directions. But yes. Okay, so like I said, we're going to condense. Basically, we're going to kind of combine our logs, then we're going to expand, kind of separate them. So like log base 3 of 24 minus log base 3 of 8, keep the same base, but you would divide the 24 and the 8. So like I said, I'm writing it out, but like I said, if you want to jump straight to your answer, knock yourself out. So that would just be 3. And this is an example of a log that really does, like 3 up to what power would be 3. Well, this would really simplify to 1. I don't know if that makes sense, but sometimes if you see it evaluates nicely, you might want to get into a habit of doing it. Because remember, if you did do like the section from this, remember when you evaluate a log, you take the base up to what power would equal your input, like your big number with your log. Same idea with 8. This would be log base 2 of 15 over 15. So that would just be log, like if I can skip the step, this would just be log base 2 of 1. And then if you want to simplify this 2 up to what power equals 1, well, 0. Like, kind of simplifies nicely if you see that. Like I said, some of these don't simplify nicely. That's, for example, like why I didn't simplify number 1. 2 up to what power equals 28. That doesn't really have a nice answer. Like that's where you'd have to use the change of base formula from yesterday's notes. Similar idea with number 9, though. You'd have log base 4 of x to the 9th over x squared. So just kind of use your exponent properties. Remember, you subtract the powers when you divide. So that would be x to the 7th. Okay, and then we're also going to expand using this property. And like I said, same kind of idea with these two questions. I think 10 and 11 are a little bit silly because you probably wouldn't ever use this in an actual kind of application that I can think of at least easily. But you could think of two numbers that divide and give you 4, and you could rewrite it. So you could write this as log base 8 of 16 minus log base 8 of 4, because for example 16 divided by 4 would give you 4, but you could do anything else. Like, I mean, you could do 80 and 20, like that would give you 4. I mean, like, so like there's an infinite amount of answers you could really, if you had to expand this. And you could even expand it with more than 2 logs potentially, if you could think of like a number divided by 2 different numbers that gives you 8. But I'll be honest, I'm not a huge fan of like questions 10 and 11. So if I'm losing you with these ones, I'm sorry. For this one actually kind of makes sense. You could basically put your 1 and then subtract the 3, because like 1 divided by 3 would give you the 1/3. Like 11's not as bad. You could also come up with different numbers that divide and give you 1/3. Like you could do log base 5 of 15 minus log base 5 of 5, for example. So if I'm losing you with 10 and 11 or questions like 5 and 6 above, don't worry too much, because I think they're kind of weird questions, to be honest. But 12, like I said, this is where you, like, I mean, when you need to separate your variable from your coefficient or your numerical value. I mean, this would just be log of m minus log of 7. So basically, anytime you see division, you can kind of write it as subtraction with 2 separate logs, or if you see logs that are subtracted, you can combine it like with division of your inputs. Any questions about the quotient property? But pretty similar idea as the product property. I mean, just division and subtraction instead of addition and multiplication. So pretty similar ideas. The power property might be kind of the weird one of the group. Basically, if you have your input up to a power, you basically can put the input in front multiplied to your logarithm. Or if you have a number in front, you can basically raise it to a power. So let's look at, like, I think this, might be some questions about this one. So for example, if I'm condensing, like for example, I could bring this 5 to be a power. So this would be log base 4 of 2 up to the 5th power. And then you could simplify that. And that would be log base 4 of 32, because 2 to the 5th power. So if you have like a number or a coefficient multiplied in front, you can basically take it to a power of your input part. So this would be log base 2 of x to the 7th. This one, you could just write it as log of 8 up to the 1/3 power. Remember, the 1/3 power is really like a cube root. So the cube root of 8 would be 2. Remember, that's like your power on top, that's your root on the bottom. Like remember, like a 1/2 power is like a square root. A 1/3 power is like a cube root. 1/4 power would be like a 4th root. If that makes sense. And then to expand, similar idea, basically you just take your power, bring it in front. So basically the reverse of what we just did. This would be 7 log base 2 of 8. If you have like a more going on in your power, you have this x minus 1. So you take the whole thing, you're going to multiply it by this 3. So this would be 3x minus 3. You distribute times log base 4. And this last one, like I said, remember a square root's really like a power of 1/2. So you could bring that 1/2 in front. these are kind of like the three properties we're going to be using. Because we're gonna look next, like on the back side of this note sheet, like there's just gonna be some problems where you have to use multiple of these properties, but these are kind of like the three properties you'll come across with logarithms if you're dealing with them, even in like future classes. But any questions about the power property? I think this one might be the kind of a little bit of the weird one in the group. It's nice though when you can get rid of a power though, because then sometimes it makes it easier to evaluate what you have, or you can start doing other rules. But keep these kind of properties in mind, and they're really familiar with me, so I don't want to kind of take it for granted. But when I'm doing these examples on the back page, but once you get like comfortable with these, you just kind of start seeing the rules, and it does get pretty easy like once you get it down. But I know definitely when you're starting, it probably is a little bit weird. So I want to try and make sure I'm kind of looking at it through like your lens versus my lens, because I've done a lot with logarithms, obviously, just from teaching them so much. And then even in college, like in some of my calc courses, they come up. But so on the backside, there's kind of two sections. We have a section where we're just condensing logarithms, and we have a section where we're expanding logarithms. I don't even know if we have enough time. I'm probably not going to do all of these problems, so I might skip some of them. And like I said, I'm going to be trying to show you a lot of my steps, but when you get good with these, like you're welcome to skip as many steps as, like, if you can be like, oh, I'm going to square this, and then I'm going to divide them, and you can kind of do that in your head. I mean, feel free to do so. But for this problem, one thing that might be a helpful tip, you always want to look for the power property first. That should always kind of be your first kind of priority. So anytime you see a number like in front multiplied to a logarithm, remember you can take that and raise it to be a power. So like this first log would really be log 6 squared would be 36. And then since it's subtraction, remember subtraction means you're going to divide your input. So this would be log of 4, because 36 divided by 9. And I don't know if I need to, maybe I'll write that. But like I said, I mean, if you could go straight from the original problem to your answer, that's fine with me. I don't need to see all your individual steps for some of these. I might ask like on your quiz, maybe like, please make sure you show me your steps. I mean, if I ask for it, but just to make sure you understand the properties. But I mean, realistically, when you get good at these, you shouldn't need to write each individual step. But I mean, if you need to, I mean, obviously do what you need to do. But if you could see like in this head, oh, I'm going to square the 6, and then I'm going to divide by 9, like, and you can do that all in your head at once. Like some people might even just write it, like they might just see it's like, oh, the 6 is going to be squared, and then I'm going to divide by the 9, and they might just go straight to their answer, if that helps as well. Like there's definitely different maybe approaches to thinking. But like I said, you always usually want to deal with the power property first. But so question 20, kind of same idea. You're going to take the A up to the 4th power. You're going to take the B up to the 2nd power. And then you could, since it's addition, you would multiply your inputs. So you just have A to the 4th times B squared, like being plugged into the log. Try not to be, I'm trying my best, but just make sure when you're writing your base too, like that should be kind of, make sure it's small so it doesn't look like it's part of like your input. Any questions so far? I hope we'll see how this is going. But like I said, I'm going to have you start working. Like I have an assignment in Delta Math. I'll have you start that like this week. But if we need to spend more time with this when we come back from spring break, that's okay. I mean, I just wanted to kind of at least introduce it before we went on break. I mean, some of you guys it might click really quick. But like a question like 2021, I mean, you're going to do the power property. So like take those coefficients in front and raise like what you have up to that power. So that'd be u to the 7th minus log base 4 of v. Just be careful if you already have a power. Remember, you're just going to multiply like 2 to the 3rd. Like if you have a power to a power, you multiply, so 2 times 3 would be 6. Then you're just going to divide what we have, and keep in mind this is a U and this is a V, so we can't combine. I know my handwriting, they kind of look the same. It's a U on top, so you can't do anything like from here. Maybe just to kind of like 22, maybe to kind of demonstrate if you have more than one thing. So here's how I would do a question like 22 if this kind of demonstrates. So we're at one, there's no power rule, so I don't have to deal with that. But I have a 15 plus a 4, so I multiply. So I'm going to have 15 times 4. And then since I have a minus a 6, that's going to be division. So I'm going to divide by 6. So basically, you can kind of do multiple steps at once. So this would just be 60 over 6. That would just be 10. Um, 23 and 24 get a little bit, there starts to begin a good amount going on, and then 25 and 26 as well. But we're starting to get kind of a lot going on. But basically, like I said, I would do your power rule first. So like this would be a 1/2 power. So I know the 49, that's really the square root of 49. So that's just going to turn into a 7. Like this is going to turn into a 7. So then if I look at what I have log base 3. I have a 4 plus a y. So that's going to be 4 times y, or just 4y. And then I also have a plus 7. So I'm just going to have times a 7. So there's no division because there's no minuses between these logs. So that's why I was kind of writing it like that. I should have wrote it a little bit bigger, but I thought I might have to divide. So I mean, this would just be log base 3 of 28y if you want to just kind of clean it up. And maybe I'll just do one more in this section. Maybe I'll leave 25 and 26. Yeah, that doesn't look like there's anything too crazy going on there. I will post I do have like a key. I'm like actually kind of, I made sure I got the key ready. So I will be able to post like a key, and I'll have all the problems, but I'm going to skip 25 and 26 for now. But if you see a question, 24 is a good one to look at. There's kind of 2 ways you can think about this. Basically, since this is distributing, basically you're going to take each one of these up to the 1/3 power. So remember, the 1/3 power is like the cube root. Like the cube root of 8 would be 2. The cube root of 27 would be 3. And this just comes down. But then like when you have like multiple logs like this, just kind of look at when you're adding and just subtracting, just look at what you got. Like you've got a 2 plus a 3. So that'd be 2 times 3. And then a minus a 3, that's going to be divided by 3. So I mean, really the 3's just cancel. I mean, or you could have actually just kind of looked at it here. You have plus log base 5 of 3 minus these basically just cancel because it's the same thing. But like I said, I'm going to skip 25 and 26. There's nothing super crazy going on there. But then we're going to look in this section, we're expanding. So expanding your goals to kind of like separate every piece you can. So basically you have an X part, you have a Y part, and you have a Z part. So basically, if you have 3 variables, you're going to have 3 logarithms. So I'm going to do the X log first. We just have log base 6 of X, nothing crazy going on there. Since this is multiplication, we're going to have plus signs. I'll do the Y part in green. I mean, the Y part, nothing else going on there either. So it's just going to be log base 6 of Y plus. Okay, this Z part, you can either do it all at once, but you have a 4 as your power. So, I mean, you could just write it like this.
Good morning, Garfield Heights High School. I just want to take a moment to acknowledge a few students that have been showing.
There is an announcement, so I'm going to just, so sorry about that. But remember, when you have a power, the power comes in front if you use that power property. So you could just like, so I would kind of just do that all at once. Like I see there's a power. I know I'm going to have a 4 in front, but if it helps, you could write it like this and then move the power if you want to take 2 steps. So I don't know if that's like too much for like the start, but that's how I see it. I mean, like if I have a power, I'm going to have a coefficient. Like this was a y squared, I'd have a 2 in front here. Or if this was x to the third power or something, I'd have a 3 in front of my like first log. Similar kind of idea with the log base 4 of this. Remember, this is division, so we're going to have a minus sign between our two logs. We're going to have two logs because we have an a and a b variable. So this would be 9. Like the 9's going to go in front. So like it would be 9 log base 4 of a minus log base 4 of b. Because remember, like the power comes in front. So like I said, I don't know if me skipping a step is too much. I might need to kind of reapproach this, but let me know, especially if I'm losing any of you guys. I don't know how we're feeling so far. Not seeing much. All right, I'm just gonna do maybe one more, just so you can see if you have like the whole thing up to a power. Basically, if you have like the whole input up to a power, you're gonna put a 2. And you're gonna put like a set of parentheses, then just kind of ignore this power for right now. Like write it like you would. Well, that would be 4 log base 7 of q plus 2 log base 7 of r. And then this 2 just multiply like to your coefficients, or basically double your coefficients. So that would be 8 log base 7 of q plus 4 log base 7 of r. So if you have like the whole input up to a power, you kind of want to pull it in front and then just kind of get your answer and then just basically distribute that the power to a power basically. You also could, I guess you also, another way, I guess if that's confusing, I guess you could just, you could just bring this power. This would be an 8, this would be a 4. I mean, and then you would just get this answer too. So maybe that might actually be an easier way to think about it. Like this problem, you'd really have y squared over z to the 10th. So if you deal with the power first, I guess you wouldn't have to deal like this. The answer to this one, you'd have 2 log base 2 of y minus 10 log base 2 of z. So like if you deal with the power, like it basically goes away. So that might be an easier way so you don't have to distribute. Let me